Next misconception. It is the misconception that this is actually one of my favorites. LLM judges are only for developing things. They can be utilized for development. When you are developing your LLM applications, automations, and agents, you use these metric judges to measure. So you arrive and converge at the right solution quicker with more confidence. Well, that's true, but that's not only for only pre-production and development time. And there are a bunch of reasons for that. And the reality is you can use and you should use LLM judges also in production as live guardrails. Now, there's a there's a great paper actually I'll be mentioning in a minute. Um, it shows that, and we also know this empirically, almost everybody knows, but the paper quantifies it. It's a paper from Nature. LLMs can perform pretty complex tasks before being flawless in very simple tasks. And this has a very important consequence. And the consequence is that you cannot draw a boundary or a threshold and define this is the safe, reliable zones for LLMs. It just doesn't work like that. They can do really complex reasonings and things of that sort and still fail in super simple tasks, meaning that you have to one-off evaluation during development is not enough. You actually have to measure and monitor LLM automations all the time with low latency at scale with these judges in production because, as Ari also mentioned, this technology is inherently unreliable and unpredictable. It is just how it is. Um, and I would like to also emphasize this paradigm is even new to machine learning experts and some data scientists who are not maybe well versed in generative AI part. So because in traditional machine learning, evolution is of course extremely important, but it's not really a problem because traditional machine learning, or maybe not traditional, but let's say discriminative models, meaning non-generative models, well, there are text classifiers and image recognizers and things of that sort. You can basically calculate ratios and proportions to measure your text classifier. It's just accuracy. It can fail only in these specific ways. So in traditional machine learning evaluation, you have a test set and you train your models and you calculate your accuracies and precisions and recalls or sensitivity or specificity or some computer vision related metrics and things of that sort. And if it is performing good enough for your use case, you go to production. There's no such thing as live production evaluation. There's no such concept actually. It's not very common because um, you have established the decision boundary and the reliable zone with non-generative models because they are working in expected ways. Even if they make mistakes, they fail in expected manners. So you have much more control or your expectations align with that. But generative models, as I mentioned previously, it doesn't work like that. And this is the paper actually from Nature. It's a recent paper, and it sums up what I mentioned greatly. But there's a even more interesting fact. I would maybe call it a bummer. The fact is that more instructable, larger, more smarter models, they are actually less reliable. So all these GPT-4s and Anthropics and all these foundational models, they can do pretty complex tasks, but they are even less reliable. It's even harder to draw the decision boundary. Hey, these kind of tasks, I can just rely on it. It just works all the time. You cannot do that. So bigger models, they are less reliable. More powerful models are less reliable. This is quite counterintuitive.